Alright, silly people, here's the situation. This problem has to deal with the concept of degeneracy, which hasn't really come up in Griffiths problems before on this channel. But um, if two wave functions satisfy the Schrodinger equation and have the same energy, E, then those two wave functions are said to be degenerate. Um, and so what we're going to do is we're going to prove that in one dimension there aren't any degenerate wave functions, starting with the assumption that psi1 and psi2 are degenerate in one dimension. Uh, so we've got two Schrodinger equations that we can write. This is going to be the one for psi1. Oh my goodness. It's del squared psi1 del x squared plus v psi1 equals e psi1. And then we've got another Schrodinger equation here for psi2. Same potential, same energy E. Okay. Griffiths suggests that we take this first equation and multiply it by psi2. So let's do that. We've got this thing, and now we have plus v psi2 psi1 equals e psi2 psi1. But we know what e psi2 is. It's given by this equation here. So let's plug that into our equation on the left-hand side. And that's going to be real interesting because we have minus h bar squared over 2m del squared psi2 del x squared plus v psi2 times psi1. So carrying out that multiplication on the right hand side and also writing the entire left side again because I'm a numpty. It's minus h bar squared psi1 over 2m times del squared psi2 del x squared plus v psi2 psi1. And then you see that the potential term gets canceled out, right? And we can also get rid of the h bar squared over 2m nonsense. And what we're left with is psi2 del squared psi1 del x squared minus psi1 del squared psi2 del x squared is equal to 0. And then we recognize the fact that this is just the result of a product rule derivative of a certain combination of wave functions. So this is going to be of psi2 del psi1 del x minus psi1 del psi2 del x, and that is just saying that if you do the product rule on this thing, you're going to end up with a couple of terms that do end up canceling out, and then these things are going to be left over. Right. Which means that this here quantity is a constant in x, which means we can define it to be whatever constant we want. Let's call it just c for constant. And it's going to be true for all x, including infinity. So let's plug infinity into these guys. We've got evaluated at infinity minus psi1 of infinity del psi2 del x at infinity should still be equal to c. But now on the left-hand side, we just have a bunch of zeros because wave functions at infinity always go to 0, and so do the derivatives. So we have 0 on the left-hand side equals c. So that's interesting. The constant is 0, which means we can rewrite this equation now as psi 2 del psi 1 del x equals psi 1 del psi 2 del x. And then you can do the same sort of trick where you see that this is a product rule, and then you just see that psi 1 equals psi 2, right? Which means the wave functions are the same, but that would contradict our first assumption that psi 1 and psi 2 were different wave functions, just with the same energy, E. So we've proven by contradiction that there are no degenerate wave functions in one dimension. All right.